Okay, go ahead, please.
Okay. Y equal to 18.
Yes.
18.87
18.87, yes.
times
Times
0.0697s.
0.069
7s.
7x. Okay, this is right, but somehow, but it's not taking this form. It's supposed to take this form.
Okay, maybe I would say exponential that's exponential 0.0.
Okay, so exponential what?
Exponential 0.0697s.
To the power of
Or you can say times 2.71, which is exponential raised to the power of 0.06.
okay. Okay, so you think this should be it?
Yes.
Okay. But there's something I want you to see here. This one, this value is this. This value is this. So if this value 1.63572 is e to the power of b, what is b then? Because this is what you are trying to express now. So you need to get the value for b. If all of this, wait, how did you get this 0 point something?
Standard error.
No. We are supposed to focus on this. This and this is what you use to form your equation. This one you are saying now is the slope. It's something like the slope, the coefficient of x. This is the intercept. Okay, so this figure, this e to the power of b is 1.63572. What then is b? So you need to be able to estimate the value of b so you can use it for the equation. So let's start by trying to estimate b. Okay, so if e to the power of b let's say e to the power of b is equals 1.63572. What does that mean? That simply means that b is equals the natural log of 1.63572. But is this looking strange? Let me use
No,
log.
sir.
Is it?
No.
Want me to? Okay, it's clear, right?
Okay, you can just use another way. So
If,
say
for
it.
example, I can say if 10 to the power of um, if 10 to the power of 3 equals 1000, therefore means that log base 10 of 1000 equals what? Equals what?
Two.
Equals 3. Okay, that's exactly what's happening here. This 3 is like b now. E to the power of b equals that. Therefore, log of this is equals b. You understand? So, what is that? Does that tell us now? That shows us that b, the value of b is equals what? It's equals this one. This is the value of b. This is the value of b now. Which means our equation, our model is y is equals what? So can you give it to me now? K is what? K is the slope
18
equals
points.
18 point
87
87 times what?
times 1.63.
No, we are going to do this times e
Okay.
to
Times
the power of 0.4208x. This will be a power now. I just want to format it to look exactly the way it's supposed to be. Something like this. This is the model. Let's go and check what our scatter plot gave us the other time to see if it corresponds. This is what the scatter plot gave us. Remember, it's the same data.
Yeah.
18.86 something e to the power of 0.4921. And that's exactly what we have here. 0.4921. 08. It was approximated there. So this is the regression model given by the Logest function. Hope is understood. Understood? Is it clear, please?
Yes, it's clear to me. So
Okay. Who else is still with us now? Um, Ustaz Ezekiel.
It's clear, sir.
Okay.
Yeah, yes, sir. It's clear.
Okay. Suppose I ask you now, I say using this model, forecast the value of sales if 2.5 million is spent on adverts. That's using this model above. Now you try your hands on this. This is not a linear model now. This exponential model. So using this exponential model, you try to forecast the value of sales if 2.5 million is spent on advertisement. Well, you want to try your hands on that?
Okay, so let's give it a try and see.
Okay, so let me give you at most 5 minutes to work on that.
Okay.
So are we done? Are we done with the computation?
Shit.
Are we done?
Not yes. Not yes, sir.
Okay.
Convert the
Okay. Okay, so let's do it. So we're going to say y is equals the y, which is sales now. Sales, which is also called y. Equals what? 18 points. Well, let's do it this way. Let's do it this way. Okay, so K is what? Hope you know that K is the What's K?
Is it constant?
Yes. Intercept, yes. K is what? 18 points. It's something. It's 7. So what about B? B is what?
0.4921.
Yes. 0.4921. So now it's easier to get y. Y will be equals what then?
2.5.
Just use this formula. Okay. Y equals 18 points. Sorry. You don't need to type again. Just click here, right? Times. Hope you are following.
Yes, sir.
Times e to the power of b. You can use the value of e there, 2 point whatever, okay? But another way you can do it is just to use the exponential function of b times, what do you think should be here now? 2.5. Okay. Alternatively, could have used, I could have put the x here as well to make it standard. What's the value of x? 2.5. So here, instead of this one, I just click x. So that's it. Does it look realistic? Let's look at it. When sales is 2.5, we are saying y will be 64. Let's see if it looks realistic. Let's do a scatter plot here. Insert that, that. Then add the trend line, exponential, more options. Why is it giving the exponential? Come to display and display arrow squared value. So now we are saying when it is 2.5, if this line is to continue like this, the way it's going, you know, it should be somewhere around here, isn't it? Hmm? So it makes sense, right?
Yes, sir.
It makes sense. If it's to be extended, you see that to be around somewhere between 60 and 70. And what we got is 64.5. So it makes sense. It's realistic. So that's that. So that's how we use the Logest and the Linest function. So of the three methods, which do you prefer? Which do you think is the best?
It's the linear.
No, I mean
Linear.
data analysis, scatter plots, and these functions, Linest and Logest function. Each one has its own special feature, right?
Data analysis is
You see, each one has its own special feature. Can you see here, we are using both the scatter plot and we are using scatter plot to confirm our result, whether it makes sense, isn't it? Is that not so?
Yeah.
So you
Yes,
can
sir.
actually use multiple methods,
yes, sir.
you know,
Yes, sir.
to ascertain if your result is actually realistic. So sometimes some of these things, not a question of which is better, it's a question of using each of them or all of them to your advantage. Okay. So that is that. Let's look at something else. I want to believe that's very clear. Okay, so now let's look at something else. Let's look at moving averages.